Hey, it's Coach Reeves. Today, we're going to rationalize the denominator. Now, you've done this in the past. You've done this when you were in Algebra 1. But just like when we simplified radicals, times have changed. We're taking it up a notch because we're in Algebra 2. Okay? So we're going to start simple, but we're going to start building because we're going to put in higher roots and we're going to add exponents, okay, on the variables. All right, so check this out. Here's the rule. The rule that we know is you cannot leave a radical in the denominator. And we dealt with square roots the whole time, and we got to where we were pretty good at it. We would say, oh, yes, I'm going to multiply times the square root of 3. And whatever I did to the bottom, I would do to the top. And we would say that the square root of 3 times the square root of 3 turns out to be the square root of 9, which is a regular 3. And then we would multiply 5 times 3 and get a 15 at the bottom in the denominator. And then we would say the 2 is on the outside. We would say that 5 times 3 turns out to be the square root of 15, and we would be done. Yay! This is the way we're starting, just to remind you of what we were doing in the past, okay? The rule is no radicals in the denominator, okay? All right, let's try another one. Now, here's my thing. Still simple, still just basic square roots, but here's what I'm going to ask you to do as we move forward. If you can reduce before we rationalize. Now, look at the 3 and the 6. The 3 is underneath the radical. The 6 is underneath the radical. Since they're in the same position, you need to reduce first. You need to keep everything smaller instead of reducing or simplifying later on. It's a lot easier if you do it at the beginning. So you're going to reduce, and you're going to say that 3 goes into 3 one time, 3 goes into 6 2 times. What is the square root of 1? 1. So you're looking at 1 over 5 times the square root of 2. Now this problem is very similar to the problem right above it we just did. You would step in and you would multiply and you'd say, okay, I'm going to multiply times the square root of 2. Whatever I do to the bottom, I do to the top. Square root of 2 times the square root of 2 is going to give me a 2, because that is the square root of 4 is 2. You're going to multiply and say 5 times 2 equals 10 in the denominator. And you're going to say 1 times the square root of 2 is the square root of 2, and you would be done with that problem. But the whole point of me doing this problem is you need to reduce the radicals before you rationalize. Reduce before you rationalize, okay? Next problem. This is why I was talking to you. We're going to reduce first and then rationalize, okay? What do you have inside? I have a 12 and a 2. We're going to reduce. The number 2, the number 4, excuse me. The number 4 goes in here 3 times. 4 goes in here 5 times. All right, so we've reduced the numbers, okay? Look at your exponents. Look at your variables. Look at the x's. X to the second over x to the third. This is going to reduce to x to the first power at the bottom in the denominator. Y squared over y to the fourth. This is going to reduce to y squared in the denominator, okay? And then we know what the square root of y squared is, but we'll take it in steps, okay? In case you forgot, on these exponents, we had x to the second over x to the third. X times x, x times x times x, cancels, cancels. That's why we were left with x to the first at the bottom. So let's write down, let's look at what we have left over. We have a 2 in front. We have the square root of 3 inside. That's all we had. In the denominator, we have what? We have the square root of 5. We have an x inside. And we have y squared. But look what we have. There's an invisible, remember there is an invisible little 2 sitting there. And you're going to say that 2 goes into 2 how many times? 1 time. That comes out. The y gets to come out. Now, can we simplify this? What do we need? Our goal is to make the root match the exponent. When the root matches the exponent, it came out. Just like when we are simplifying radicals, we want to get the root to match the exponent so it can come out. Okay? So there's, like we said, there is an invisible little 2 sitting right here. And there's an invisible little 1 sitting right here. An invisible 1 as an exponent right there. So when I multiply, I'm going to multiply times the square root of 5 to the first power. X to the first power. Now, why do we do that? Because when we multiply, we are taught to add exponents. So look what's going to happen. This would give me the square root of 5 to the second power, x to the second power. You see this? 1 plus 1 is 2. 5 times 5 is 5 squared. X times x is x squared. That's what we're trying to do. We're trying to get the root to match the exponent. And when the root matches the exponent, it drops out from being underneath the radical. Because what is the square root of 25? 5. What is the square root of x squared? X. So what are we left with at the bottom? Well, remember, whatever we do to the bottom, we have to do to the top. So what is this going to leave me? I have a y outside. I now have a 5 and an x outside. That's going to leave me in the denominator 5xy. In the numerator, the 2 stays outside. And then we multiply, and we get 3 times 5x is going to be 15x. We have rationalized the denominator. We do not have a radical in the denominator anymore. Now, real quick before we go any further, how did we do this? We found out what our root was. Let me circle this. We found out what our root was, and then our goal was to find out what we needed to multiply by to make the root match the exponent. You find out what it takes, what we need to multiply to make the root match the exponent so it drops out from being inside the radical. Let's try another one, because I know you're confused, but we got to keep trying. All right, look at my root. My root is a 4. So we're going to try to reduce if we can, okay? We're going to say that 5 goes into 5 1 time, 5 goes into 40 8 times. Look at the p's. The p's will reduce to p to the first. So this gives me 3 and the 4th root of 1. Well, what is the 4th root? What is 1 times 1 times 1 times 1? This is going to give me just a regular 1. Do you understand? This, the 4th root of 1, the cube root of 1, the square root of 1, this is just the number 1. So we really don't need this, because all we're going to end up doing is multiplying 3 times 1, and we're going to get a 3. All right, so that's going to give me a 3. On the bottom, in the denominator, we're going to have a 4. We're going to take the 4th root, there's our root, and we're going to have an 8, and we're going to have p to the first. Now here's the tricky part. Do you know how to rewrite the number 8 as an exponent? You got to use your thinking cap. Think about what you've done in the past. And this is what's going to bother some people because they're not creative. But 8 can be written as 2 to the third power. And that is p to the first power. Did you remember what our goal is? Our goal is what? To get the root to match the exponent. What do we need to multiply times? Well, we're going to multiply. Make sure you use 4. I'm at 2 to the third power, but I need to get it to the fourth power, the fourth root. So if I multiply times 2 to the first, when you multiply, you add exponents. 2 to the third times 2 to the fourth, 2 to the first is going to give me 2 to the fourth right there. If I have p to the first times p to the third, 1 plus 3 is 4. That's going to give me p to the fourth. My goal to make this stuff disappear from being in a radical is to make the root match these exponents. So you find out how many more you need. If I have 3, then I need 1 more to get me to 4. If I have 1, then I need 3 more to get me to 4. You try to get those to match. Because once they match, they drop out from underneath the radical. Because you're looking at this right now. The root matches the exponent, so a 2 would drop out. The root matches the exponent, so a p would drop out. Whatever you do to the bottom, you had to do to the top. So this is what we figured out to do to the bottom. You have to do that to the top. Okay? Now, so what does that leave me? It leaves me 3 on the outside. That leaves me with the fourth root of 2p to the third. Look at the denominator. What did I have? I already had a 4 on the outside. I had a 4 sitting here, and they ended up taking out a 2p. So what is 4 times 2p? That gives me 8p. In the denominator, 8p. And that would be my final answer, right there. Still, it's going to take practice. Let's see if I have one more. I think I might have one more for us to practice with. Yes, taking the cube root. Our root is 3, okay? All right, so we're going to ask you to use your brains. Can you reduce? Okay? Look at what you got in the problem, okay? Can you remember when we simplified radicals? Look at this guy right here. Don't let this guy make you panic. We're taking the odd root of a negative number. I would ask you to get rid of this, take care of this right now, that when you take the odd root of a negative number, no matter what, -1 comes out. I would deal with that before I even got started. And this would turn into -2 times the cube root of 2m squared over 5 times the cube root of 9m to the third. So the first thing I would do, before I even got started, since I'm taking the odd root and I have a negative, I would take out the -1 and multiply and do that first. Now see if you can reduce. I cannot reduce the 2 and the 9. But can you reduce the m squared over m? Yes. This will reduce to just the number m. So what we're looking at is -2 cube root of 2 over 5 times the cube root of 9m. Now let me raise this up so you can see what we're going to do. This is what we have to simplify. Put on your creative hat again. Put on your thinking cap. Is there another way that you know how to write the number 9 as an exponent? Hopefully you can see that I can write the number 9 as 3 squared, 3 to the second power. That's the equivalent of 9. Do you remember what your goal is to get rid of the radical in the denominator? Your goal is to make the root match the exponent. The 3 has an exponent of a 2. The m has an exponent of a 1. To make them match, we're going to multiply times the cube root, okay? The cube root of what? 3, this is a 2, so I need 3 to the first power. Because 2 plus 1 is going to give me 3 to the third. This is a 1, so I need 2 more. 1 plus 2 is 3. Now my root matches my exponent. They will drop out. This is going to drop out a 3. This will drop out an m. Remember, whatever we decide to do to the bottom, we have to do to the top. So I'm going to have to multiply the top of my fraction times 3m squared. Negative 2 is on the outside. On the inside, 2 times 3m squared will give me 6m squared. Over, what do I have? I have a 5 already outside, and now I have a 3m. 5 times 3m is 15m. And there's your answer. Okay? All right. So again, it's not what you've been used to doing as far as simplifying the rationalizing the denominator. Okay? Used to be easy when you were in geometry, and it was only square roots, and there were no variables involved. But now we're in Algebra 2, and everything has to get a little tougher. Okay? Now, you can do this, but it may take you some practice. Okay? If you get stuck, please email us, let us know, show up in the Zoom, let us help you. Okay? See what you can do. Good luck.